Hello and welcome to grade 11 college math. We are in unit 4, trigonometry, and we're just starting with lesson 1 today. Today we'll be covering 3 topics, the Pythagorean theorem, and then the trigonometry ratios that for finding side length and finding angles. So it will be a longer video, so please see it all the way through. Some of this stuff. Okay, so we're going to recap Pythagorean theorem really quickly. You've seen this before in previous grades, so it's really just a recap. So let's go through the definition. So in a right angle triangle, the sum of the squares of the two legs, which are the two sides that form the right angle, equals the square of the hypotenuse, which is the longest side. So we see here we have the hypotenuse pointed out. Okay, we have one leg and the second leg. Okay, and there's the right angle symbol you'll always see. And we like to use a labeling of A, B, C. And it could, you're going to come into other triangles that are named XYZ and LMF or LMN, for example, or PQR. That doesn't really matter, but what matters is the vertices are written in uppercase and the sides are written in lowercase. You'll notice that vertices A is across from side A, vertices C is across from side C, and so on and so forth for B. So what derives out of this idea that when we square C, square B, and square A, if you were to add up the area of this A square and the area of the B square, that it would equal the area of the C square. So therefore, they come up with this formula right here. You've seen it before. All right. So here's an example. So we'll just go quickly to do 2 examples. Find the unknown values. Round to 1 decimal place. So that's good that they tell us. Sometimes they don't tell us, and we're not sure how many decimal places. But anyways, now it says solve the unknown values. So that includes this theta right here, the angle. So the first thing to do is take 180, which is the interior sum of the angles of a triangle, subtract the 90 and the 31, and you're going to get an angle of 59. So this angle here now is 59. Now going to the sides, you may want to label your sides A, B, and C. Always do the C across from the 90 degrees, right? That's your hypotenuse. So we put in 3, we put in 5 equals, now C we replace with X because on the side for C, we actually call that side X as a variable. You could keep it as C, but in this case, when we substitute 3, 5, then we should put the X in because that's what it said it was. So, very important thing is notice that they have squared 3 to make 9, and they squared 5 to make 25. Then, only then do they add it up. Okay, so a lot of mistakes happen when people do. I've seen lots of students do 3 squared plus 2 squared equals 8 squared, and then get 64. So that's completely wrong. We don't want to combine that. So following the rules of BEDMAS, you do each each square first and then add up the result. So we square the 3, we get 9. We square the 5, we get 25. So I just thought I'd mention that common error that students do make. All right, so the square root of 34 then, and to get rid of this square on the x, you must square root them, right? So then you square root both sides. What you do to the left, you do to the right, and we get 5.8. Now, does it get more complicated? A little bit if you are missing one of the side legs, one of the legs. So we can find, for this example, we can do the internal angles again. 180 minus 90 minus 559 will give us theta of 31 degrees. All right, here we substitute our values, but this time we know C as 7, and we know A as 6, but we don't know B. So B, they've named, again, so if we do A, B, and C, then we rename B as Y. So what happens is the 6 is brought over here, and we change the signs. Anytime we bring something across the equal sign, we change the sign. All right, and so we have 7 squared minus, very important that we have minus, okay, 6 squared. Now it's just the 6 being squared. So it's like there's a bracket on this. We wouldn't want to square the negative and then turn this into a positive. That will really give us the wrong answer. So notice that it's the 36. That comes from the 6 being squared, it's not negative 6 being squared. So another common error that people make. So anyways, then to get rid of the y squared, we square root both sides, right? And we get square root of 13 is 3.6. We don't need to do another example, but let's say we had this side missing. Then we would have B stay on one side and A would move over. All right, so that's the recap of Pythagorean theorem. All right, let's go through the trig ratios. There are 3 primary trigonomic ratios, and they are sine, cosine, and tangent. The primary trig ratios can only be used with right angle triangles. Right angle triangles have the following features. So we have the hypotenuse. Okay, it is always opposite the right angle. Okay, we have vertices. As uppercase letters. All right. We have side lengths. Always as lowercase letters. And now to get more specific, if we were talking about angle A, okay, if we were talking about angle A, then across from it would be opposite to angle A. And then this side would be adjacent. Now what if we were talking about a different side? let's say we were talking about angle B. We had a blue theta. Well, the opposite to that would be side B, opposite to angle. Oh. Now this is just an angle sign I'm writing beside the A and the B. If this was the angle we were talking about, we would have adjacent. To angle B. Theta is always the angle of reference. The angle of reference can change. And so all our trigonometric ratios depend on the angle of reference. Whichever angle of reference you decide, then that's what determines what your opposite and adjacent signs are. And it could, if you're solving a complete triangle, you might first look at it this way and go with the green one and say, this is my angle of reference, so that's my opposite side, this is my adjacent side. Right? You might change your angle of reference on another question and say, okay, I want to work from this angle of reference, angle B. And that would mean that this side would change and now be the opposite side, and this change would now be the adjacent. So it's good to practice this. Now you might remember that there was an acronym to follow that helped us with remembering this. The acronym was SO, CA, and TOA. SO, CA, TOA. And what these really are pointing out is they're telling you what sides to use, what trig ratio to pick, and then what sides to use. So in SO, okay, at SO, we have the sine, we have opposite, the opposite side that is, to angle A, and the hypotenuse. So, I keep saying so, but we have the S. Oh, we don't want to do that. Never mind. Get a highlighter. We have the S, the O, and the H for SO. Next we have CA. When we do CA, we focus on the adjacent side. Over the hypotenuse side. So we have C, A, H. In tangent, we use TOA. And that would mean that we're doing now opposite side over adjacent. And of course that highlights the T, the O, and the A. So let's do an example now to find the length of A to the nearest tenth. So we have to look and see what is our angle of reference. So first, well, actually, we'll follow these steps. First, Label the sides of your triangle relative to the given angle. So this is the given angle, so this becomes my angle of reference, my theta. Let's write that in there. My theta, remember it's a circle with a little cross. Kind of looks like the Pepsi symbol. Okay, my angle of reference means, now I label my sides. So here's my hypotenuse. I'm just going to use a short form. Across from it, right, we got to go across. Is my opposite side. And my adjacent, or I know what I'll do, my adjacent side is beside it. Okay? So we are looking for A. So A is across from here. So this is A. That makes this side B, and this side is C. So what we do is you eliminate which one to use. So in other words, if I have SOHCAHTOA, okay, what information do I have? Well, I'm looking for A, and I know H. I'm looking for A, and I know H. So what this means is I need a combination of these three that helps me with that. So I need A and H in it. Well, the only one with just A and H is this one. These two are not going to be helpful. So I like to cross them out and eliminate them. So I'm going to pick cos. So cos theta equals, okay, look right above here, adjacent. So we're just going to use short form again. Adjacent over hypotenuse. Now we fill in the numbers. Okay, we have cos. Now, we actually know the angle. The angle is 25. The adjacent side is what we're looking for. So we're going to leave it as A, as unknown. Hypotenuse is 12. So how are we going to get A all by itself? Well, we're going to cross multiply so that the 12 ends up in front here. So our next line will look like, we're going to bring it up here. I guess we need some space. We're going to have 12 cos 25 equals A. Now, very important that we do not do this. We do not do cos 25 and 12 times 12. Because what that's going to do on our calculator is it's going to interpret that it's 25 times 12, then being applied with the cos. We don't want that. So make sure you do, every time you cross multiply, bring the 12 out in front. So now let's bring in our calculator. Okay, and we're going to try 12. Now this is the Desmos calculator, and you can find the sine, cos, and tan right here at the bottom. So we're going to put in cos, and you're just going to put your 25 in there, close your bracket, and we get a number here, 10.875. And it did ask us to round to the nearest tenth. So A is going to equal, a couple other little notes to make sure that we include our degree symbols when we're doing the angles. So we're looking for a side length, and we were told that these are using centimeters also. So we are going to say 10.87 rounds to 9. centimeters. All right, that's it. So let's try another one. First things first, we label our sides. Here's our angle of reference. There's our theta is coming from here. Okay, right away, my easiest one to do right away is hypotenuse. Now across, we're going to go across, and that's going to be my opposite. Leaving, the only other side left is the adjacent. Now, we also want to label our sides. So across from the A vertices is this side A. Across from the B is this side. And across from the C is this side. So again, so, ka, toa. Which combination do I need? We are looking for side B right here. So I need B and I know H. I know B and H. So let's pick a combination that has, H meaning hypotenuse. I know B and C. So B is opposite. C is hypotenuse. Let's pick the combination that has opposite and hypotenuse. Well, the sine one does. So we're going to pick the sine and eliminate these two others. So we're going to go sine of theta equals, now we check up here, right? Sine is opposite over hypotenuse. Opposite over hypotenuse. That's what SO is telling us. S-O-H. S, O, and H. The sine of 10 equals, what's above? So what's our opposite? That's our B that we're looking for. And our hypotenuse is 15. Let's bring this up here to continue. We're going to cross multiply the 15 up. I better do it in a different color. I'm going to bring the 15, cross multiply. But the 15 goes out in front, remember? We have to do that. 15 sine 10 equals B that we're looking for. So let's try that out. 15 sin or sine 10, and we get number 2.6. B equals, we're looking for a side length here, and they used meters in our example from the hypotenuse. So 2.6 meters. Let's just clean that up a little bit. 2.6 meters. Very good. Let's keep going. All right, this one. So we've seen a cos example, a sine example. Well, guess what? We're going to get to see a tan example here. So let's label our sides. Actually, yeah, I think we're going to, let's do that first. A, B, and C. All right. Now let's label them as opposite, hypotenuse, and adjacent. Now you'll notice I abbreviated the sides even more to just say O, H, and A. That's acceptable, I think. Okay. Now we're going to say we're going to go through SOHCAHTOA again, decide which one we can use. Well, we're trying to solve for A, so A, and we have B. Now A and B, A is the adjacent, and B is the opposite. Remember, this was our angle of reference here. So, which one combines opposite and adjacent? Well, TOA. So that means we're not going to use sine or cos. So tan theta equals opposite over adjacent. All right, let's try it different. I got lots of room over here. So tan 40 forgot my degrees on the last question and that previous one. Okay, equals opposite, which is 35, over adjacent, which is A. We don't know that side. That's what we're looking for. So this is another bit of a different look when we are going to cross multiply here. So this is going to have to cross up, and then we're going to need AL by itself, and then this is going to have to cross down. So look what happens here. We have A, that's now up at the top here, where tan 40 was. We have tan 40 at the bottom. It's crossed down where the A is. And then the 35 is on top. And we're looking for a side length here. So let's go over to Desmos, the calculator, and we're going to go 35 divided by, and say tan 40. Bracket. We get 41.711. Now it just wants it rounded to the nearest 100th. So that means 2 decimal places. 41.71, and we were talking about millimeters in this case. Okay, so that's using trig ratios to find side lengths. Now, how do we take it one step further? Sometimes it's the angles that are unknown. These had sides that were unknown. Now we have angles being unknown. So let's quickly recap. Like I said, it's kind of a long lesson because it's 3 parts in one lesson. Anyways, let's recall again. Our sine is opposite over hypotenuse. Okay, so we have SO, ka, toa. And the first letter of each thing is what the order which we do. So in other words, S for sine, O for opposite, H for hypotenuse. So we end up using those to help us. Now, for every trigonomic ratio, there is an inverse. Inverse ratio. It is used to calculate angles. Inverse ratios are usually found on the scientific calculator by using the second function or the inverse or the shift key. So you have to find that on your calculator, or we'll look at it on the Desmos calculator in a second. The inverse of sine is simple. Remember that when we did, sorry, up here in the corner here, when we did the exponent laws, and we said the opposite of this is x to negative 1. Okay? And we said this is when we flip the x. So if we had x squared, the opposite would be 1x to the negative 2. Conversely, what if we had x negative 2? Well, what would be that? That would be 1 to the x squared. So anyways, we're not unfamiliar with the fact that we've used inverse ideas with exponents in the past. So what is the inverse of sine then? Well, the inverse of sine is sine negative 1. What's the inverse of cos? Cos to the negative 1 and tan to the negative 1. So let's practice how we can use our calculator to determine these angles when we're already given the ratio. So a reminder, the whole point of doing sine is opposite over hypotenuse or cos is adjacent is that these divisions give us a ratio. okay? A ratio for side over a side, and that ratio gives us a constant of what that angle would be in that situation. So given each of these ratios, we can find the angle. So we're going to say the angle, okay, theta is what we're looking for, is equal to sine, second function of sine, and then this ratio in the bracket. So let's come over here to our calculator, and we have to find where we're going to find that. So can't do this, so we're going to use function, and look, they all appear again. So the regular ones do, and the inverse ones do. So sine, and then 0.667, close your bracket, and we get now an angle. This is an angle of 41 point. Now, how many decimals is it wanted? One decimal place. So 8.3 is going to stay at 8. And that this is degrees. So make sure you have the unit as degrees. All right, our cos. Now, some people will do this. They'll have angle theta, which is okay, which is probably even more descriptive, probably better. Okay, let's put this in. Cos of 0.667. Now, it's no coincidence that they're trying to show you the same ratio to prove that we're trying to prove that the trig function we choose makes a difference. So whether we're choosing sine, cos, or tan. Try to make that neater, and I made it just as messy. So let's go over to the calculator. We need cos this time, and we're going to go 0.667. We get 48. .2 this time, because 0.16 rounds up to 2, and then degrees. Now, interesting fact here should be that these two, sine and cos, should add up to 90 degrees. And so 48.1, I think you can do it in your head, but 41.8 plus 41.8 plus, doing here, plus 48.2 is not accepting that for some reason. Oh yeah, 90. Okay, so good. I mean, you could do that in your head too, but okay. So here, angle of theta using second function tan gives us second function. Oh, next line, second function tan 0.667, and we get 33.7. All right, good. To find the measure of an acute angle, okay, acute means less than 90 degrees, in a right angle triangle, it is necessary to have the measure of any two sides of the triangle. So you couldn't do this with only one side. You would need to know two sides. Here are the steps to solving angles using your trigonomic ratios. First, label the sides of your triangle relative to the angle you want to find. Determine which trig ratio to use. Set up the equation with the unknown and solve using the inverse trig ratio. So let's look at this first one. Okay, so first of all, let's label our sides. So we have side C, we have side B, we have side A. All right, now if the angle of reference is here, that makes this my opposite side. This is always the hypotenuse across from the 90. And this is my adjacent side. So, well, let's check. So, TOA. Which one will I need? Well, I'm given the hypotenuse and the opposite. So which one combines hypotenuse and opposite? So I'm going to cancel these two out, right? All right, so I'm going to pick sine theta is equal to opposite over hypotenuse. I'm going to fill in all that I can with the information I have. The opposite side is 6. The hypotenuse side is 11. And this is where we make the change, right here. Okay? We are now going to a angle finding. We're trying to find the angle. So second function, that's where we put that in. So we make that jump right here. Okay? You're going to do that. Now, it's actually good if you keep it as a fraction, because a decimal you'll probably be forced to round it at some point. And we don't want to round too early. If we round too early, we won't be as accurate. So you can do sine -1, or sine, second function, sine 6 divided by 11, all in a bracket, and it will take that, no problem, like that. Okay, so we were looking for an angle. The angle of theta equals 33 degrees. Now they did want it to 1 decimal place, so good to note that. So 0.55 will round up to 1 degrees. All right, good. Now let's continue. I'm going to rewrite my SOHCAHTOA for my next time. Let's change colors so it doesn't all start to blend. All right, so things I need to do. Well, I need to label my sides. Okay, T and U and S. On the outside, I can label them as SOHCAHTOA, opposite and adjacent. So hypotenuse is always here. If this is our angle of reference, then over here is my opposite side, and this is my adjacent. So I know information for which two sides. I know opposite and I know adjacent. So opposite and adjacent, that would be this one. These ones won't help. So we're going to pick TOA. Tan theta equals opposite over adjacent. So tan theta, still looking for an angle here. So our opposite side is 4.5. Our adjacent side is 6.5. So tan, now this is where we make the change, right? So we say angle theta equals tan, second function, and in our bracket is 4.5 over 6.5. So then we're going to get an answer. Oh, I was going to try and make it therefore symbol. All right, let's do this. So second function tan, bracket, 4.5 divided by 6.5. Does that every time when I do that. Okay, 34.67 rounded to 1 decimal place is 34.7. All right. I hope this is making sense to you now. I hope you can try the next one. Why don't you try to pause the video and do the next one on your own, and then I'll come back and I'll take it up. All right, the next one, let's label our sides. We'll have side M. We'll have side K. Labeling the sides isn't as crucial in this one as the other one. It was more helpful when we were looking for a side, but it's definitely important to do your opposite, adjacent, and your hypotenuse. So across from the right angle is always our hypotenuse. That looks weird. Let's try that again. Hypotenuse. Across from the angle of reference right here is our opposite, leaving this to be our adjacent. So we know information for the hypotenuse and the adjacent. So we are not going to use, we're not going to use these two. We're definitely going to use cosine. Okay, so cos theta equals the adjacent over hypotenuse. So cos theta. Well, what do we know? So we know the adjacent is 2 meters and the hypotenuse is 3 meters. We're going to now switch to angles, and cos -1 is 2 divided by 3, and therefore our angle will be, try it over here, and now we've been able to try one of each, a sine, a tan, and now a cos. 2 divided by 3, bracket, we got 48, round 0.18, we're going to round that to 48.2 degrees. And that's the end. So now we've covered, well, that's a really good recap of everything we did last year in grade 10. It was the trig ratios in depth, and even Pythagorean theorem, always having that on your mind is a good review. So the next two concepts will be new concepts. So we'll look forward to doing that one. See you next time.